Okay, we're looking at number 7 and 8 on the review. So for number 7, it gives us a graph and it asks us to list the even and the odd vertices. So I'm going to go through and write the degree. So C, I see 2 lines, so that's 2. E, I see 3. F, I see 1, 2, 3, 4. B, I see 2. A is 2. And D is 3. All right, so my even vertices, looks like A and B are both even. C is even. And F is even. The odds would be D and E. So notice that this one has exactly 2 odds. So remember, if they're all even, I have an Euler circuit. And I have an Euler path if I have 2 odds. So in this case, I definitely have an Euler path. And I know because there are exactly 2 odds. All right, so now we're asked to find this path or circuit. So in this case, we're finding a path. So the trick to finding an Euler path is you can't start and stop anywhere. On the last page we did a circuit. You could start wherever you wanted. On this, you must start at one odd and end at the other. And this is what gets most people because they just start in a random place and then they don't know where to go from there. All right, so let me switch colors. We'll try green. All right, so I need to start at D and end at E or vice versa. I'm just going to go ahead and start at D, and I'm going to start by going to F. So I'm going to list that with a 1, and if you want to do arrows, you can. From F, I'm going to go up to A. That'll be 2, and then back down to B. That'll be 3. Now remember, I have to travel every single edge once. Now from B, I only have one direction to go. I can go to F. I've been down every edge except this one, so next I go to E. Now I've got this triangle. You can go either way around the triangle. It's really up to you. So that'll be 6, 7, and 8. Okay, so that's only one possible Euler path. There are lots of different ones. All right, number 8 asks us the difference between an Euler circuit and a Hamilton circuit. So now we're getting back into chapter 6. So Euler circuits were in chapter 5, Hamilton in chapter 6. So we've just been working on Euler circuits. And for an Euler circuit, it is going to be a circuit that travels every edge once and only once. So I think kind of the key word when you're working with Euler is edge. We're trying to get down all the edges. Now when we think about a Hamilton circuit, remember these are the solutions to our traveling salesperson problems. So a different type of problem. So for a Hamilton circuit, this is going to be a circuit that visits every vertex once and only once. Okay, so the key word there is vertex. So for an Euler, we want to travel every single edge. Remember, those are solutions to our street routing problems. So you're like the UPS guy. On a Hamilton circuit, you want to visit every vertex. So that's like starting at your house, going and running your errands. You go to Target, you go to HEB, you go to Lowe's, and then you come back home. You want to visit every location one time and then go back home.